If you have data for your application, you've probably used the database to store it. There are so many types of databases, though. NoSQL, SQL, Graph, etc. We'll talk about why you should use these different types and what their benefits are. Let's dive in.
Welcome to the Ladybug Podcast. I'm Kelly.
I'm Sydney.
I'm Allie.
And I'm Emma, and we're debugging the tech industry. How often have you struggled to learn programming because you just couldn't find the right resource to suit your learning style? I struggled for nearly a year before stumbling upon a website known as Front End Masters. I've been a long-time paid user of the online learning platform simply because I find the courses to be comprehensive and beginner-friendly. They have the best teachers in the tech industry, and they're one of the reasons I was able to land my dream job. With Front End Masters, you can learn web development, responsive design, backend development, animations, testing, algorithms, data structures, and more. You can pick a course you're interested in or follow one of the learning paths like React, Vue, Angular, data visualization with D3, Node.js, and more. To learn more, head to frontendmasters.com.
If you work in technology, chances are you've considered striking it out on your own and opening up your own freelance or consulting shop. Contract work offers more autonomy over your workday and is a great way to gain experience in new industries and build your portfolio. But often, becoming a freelance developer means you also become a bill collector, marketer, salesperson, and administrative assistant, and frankly, none of us have time for that. If you're looking for freelance or full-time work without all of that overhead, check out Gun.io. The team at Gun.io personally vets each client on the platform and pitches you to expertly match projects when you're open to new work. Get full support from the team on client interviews and let Gun.io handle contracts, invoicing, and getting you paid on time. It's freelancing without the overhead and risk, and with a platform partner who knows you by name. Apply to join today at gun.io/ladybug.
Okay, I want to start this off with a discussion about what types of databases that we've used before diving into the details and what these different types are. Emma, you want to go first?
Well, when I'm not hard coding my data, I just use Excel. No, I'm kidding.
Ooh, that's like a database.
Although Excel is actually a database, but in college we learned MySQL. That was all we learned. So only relational database, yeah.
I think I learned MySQL first. And I use Postgres pretty regularly, and I use Redis as well.
There you go.
And that's what I use. All of those three.
Very cool. Very cool. Does Spotify kind of handle that for you, or do you normally have to have another database on top of that? I have no idea how this works.
I don't know. I don't work with it.
Sorry, Shopify. Oh my goodness.
I was like,
these names.
Yeah, Shopify.
Oh my goodness. Sorry.
Shopify handles it for you. So Shopify's a managed host. So we don't do any kind of database work, but I use databases for the Shopify apps that I build.
There you go. For me, I also started off in the SQL world, Postgres. I ride or died by that for a very long time, and it's amazing. But more recently, I have been more in the NoSQL world, especially at AWS. We use DynamoDB for pretty much everything, so we'll talk about that. Question, do you all say SQL or SQL?
SQL.
Me too. But I think that both are actually right because I've heard very experienced people say SQL too. So I don't know. I always feel a little bit weird about saying that, but we'll go with it. It's one of those ones that I have to think about. So let's first talk about these two categories of databases. So there's SQL and NoSQL, and these are kind of the top level categories, I would say. SQL stands for Structured Query Language. So these are normally relational databases, and this means that they utilize joins. So joins make it so that you can store different data in different tables and then match them on top of each other. And we'll talk about this more. You essentially normalize your data. So instead of having data repeated across tables, you try to repeat your data as little as possible. So it's kind of like dry, but for your data in your database.
So, could this be like if you have a table for pet and like every row is a different pet, and maybe there's a piece of data that indicates its owner ID, and that maps to an owner table, and you've got all the owner information there. That's kind of what a relational database is, right?
Yeah, and even going further than that, if each dog had a breed, you'd have a breed table.
Mhm.
And so Golden Doodle would only appear once instead of for every single dog. So in other types of databases, you might want to repeat that they're a Golden Doodle over and over and over again. But this one, you'd have ID 3 that matches on to a breed table where ID of 3 maps to Golden Doodle.
I like this because I find it very comparable to object-oriented programming. And
Yes.
I remember in college we had to make a zoo database. And so that's always how I thought of relational databases, was like, if you had to create a zoo database, how would you break up the tables?
Yeah, that's a good one. I think that there's actually a tutorial called SQL Zoo that is very popular. So
I wish I knew about that when I was in college. I would have done better.
There you go. There's lots of different SQL databases. So it's like a family of databases. There's Postgres, there's MySQL, there's SQLite, which is interesting because it's kind of like a file within your file system. Each one has a little bit of different properties. So again, with these databases, the data redundancy is reduced, which means that there's usually better data integrity. So Golden Doodle is spelled the same way because it's only stored in there once. Instead of it being stored as 2 words in some places, golden space doodle, it's just Golden Doodle as 1 word. And so SQL databases are good for cleaning up data and having data consistency because you're using these joins instead of repeating the data and bringing in room for data errors, essentially. You use these things called foreign keys to match data to each other. So you'll have an ID and that will map onto another column or something along those lines.
Yeah, that sounds like a really good option. I mean, reducing redundancy, although I guess redundancy and replication are 2 different concepts where like you would replicate an entire database so you don't lose any information, but you're not, it's not redundant, meaning it's not, like to Allie's point, it's not like listed in several different places differently. So, I mean, like, honestly, that sounds really great. I don't even understand why there would be a different type of database. So I'm curious to see what NoSQL is like and maybe why you would use one over the other.
Yeah, for sure. So I think you actually hinted at one of the best features of SQL is that it's standardized. And this query language that you use for SQL queries is relatively straightforward. Like in teaching people to code, I wouldn't say that it's one of the things that I see people struggle with the most. It's pretty straightforward syntax and it's very declarative. It's like select star from this table so you get everything back. So it's doesn't have the highest learning curve, and that's one of the nicest things about SQL. And also this data normalization, that it's more standardized because you're using these joins and you're not repeating the data. So if you want to have lower storage, then there's that.
Really quick before we move on, every time I hear SQL, I think of little Bobby tables. Do y'all know what I'm talking about?
Oh my goodness, the best movie. Yes.
So there's this XKCD comic, and we'll link it in the show notes. But basically, it's 4 scenes. It's the first, this mother on the phone with her son's school, and it says, "Hi, this is your son's school. We're having some computer trouble." She goes, "Oh dear, did he break something?" And they're like, "Okay, in a way." And they're like, "Okay, did you really name your son Robert Drop Table Students?" And she's like, "Oh yes, little Bobby Tables." And it's like, "Well, we've lost this year's student records. I hope you're happy." And she goes, "I hope you've learned to sanitize your database inputs." We probably won't go too in depth into like the commands, but if you drop a table, it literally deletes the entire thing. So we'll link that in the show notes. Definitely check it out. It's my favorite comic.
Yeah, it's so funny. So NoSQL stands for not just SQL. So you can actually kind of use SQL within some NoSQL databases. It's not like it's the opposite of SQL, but it stands for not just SQL. And so generally with these databases, you don't have joins. So you don't have the relational model that you would within a SQL database. But then again, it's kind of interesting because this category is kind of a catch-all. It's just the alternative to SQL. So in theory, you could have joins within them. It's just generally most that you see do not have these. And this makes it so that the databases are super low latency to get data out of for the most part. So these joins are really expensive process. It's pretty computationally expensive to match all the data from one table onto the data from another table. And so NoSQL, usually that you don't have these, which makes it so it's a little bit speedier to get the data out of them. There are different types of NoSQL databases, though. So there's key value stores. So these kind of feel like a JavaScript object. There's really these two columns where you have a key and a value. Redis, which Kelly talked about, is an example of that. There are graph stores. So you would use these if the relationship between your data is the most important piece of it. So something like Facebook could be modeled with graph data because there's a lot of relationships between the different users. So Neo4j is a big example of that. There are also column stores. So if you wanted to run analytics on columns, so columns are more important than rows if you're using a column store, whereas within a normal SQL database, the rows are kind of the most important piece of data. Instead, if you're trying to aggregate by columns, you could use a column store. Cassandra is an example of this. And then there are document stores, and these allow you to store data in like a JSON or a BSON format. BSON's like a binary format for JSON. And so MongoDB is a big example of that. And in a lot of these, the data is unstructured or non-relational, so it's a little bit more anarchy, I would say, where you have more control over how you format your data rather than having to follow these exact rows and columns that you would within a SQL database. That being said, it's really hard to deal with unstructured data. So usually you do implement your own structure either on the database level, depending on the database, or on the code level. It depends on the database and its implementation. I will say that NoSQL databases are generally better at scale and scaling to super scale than a SQL database, and we'll talk about why. But let's pause here. Anybody have any conversation topics about SQL versus NoSQL, just to start off?
I just think it's confusing how many different, like Redis, Cassandra, MongoDB, CouchDB. I'm like, holy crap. Like anytime I hear these, I just get anxious because I'm like, I don't know which is which. And like, is it SQL? Is it NoSQL? Why would I like pick one over the other? It's just confusing to me, to be honest.
Yeah. Not to mention when you, speaking from experience, tweet about one of them in particular, you'll get 8 replies saying you should use this one instead.
Oh my goodness. Yes, this is so true. I think I tweeted about using DynamoDB for something and somebody was like, why aren't you using Postgres? And there are
exactly
reasons.
And then I tweet about using Postgres and they're like, well, why aren't you using Mongo? Or why aren't you using whatever else? It's like, it never ends.
It's so funny. It's so funny. People have their loyalties.
I am loyal only to myself.
Yeah. And just like as a quick side note, because I'm primarily just a web dev and I deal more with like design than I do like backend side of things. Like I could probably set up a database, but to be honest, I would have no freaking clue how to connect it to the front end. Like I have not built a modern full stack application ever in my life. And so just if you're listening and you're confused as hell, so am I.
Yeah. Like I'm working on the Shopify app, which obviously has a database component to it. It has to for a number of reasons. And I'm working with a contractor to handle the database side of things and build out the API that I need to, tap into to manipulate data, pull data, whatever I need to do, because that is not my area of expertise. And I think it's an important, point to make. Like we're talking about, giving you like a high level overview about all these things. You don't have to know all of these things. There are resources if you need them. 2, there are people if you need them. So learn what you want to learn, but don't feel bad if this is really confusing for you because it's confusing for me too.
Yeah. I think that that's very true. I would also say that nobody knows every single database. Like there are just too many that are out there. Even me, I started out as a backend engineer and I work for a cloud provider. So that's kind of in my domain now as well. But even I know like Postgres, I've used MySQL and SQLite a couple times, but it's not something that I'm like an expert at. I've used Redis in production. I've used DynamoDB pretty extensively. I've used MongoDB, and those are the ones that I really know. I've never used Cassandra in my life, for example. I know the idea behind it. Same with Neo4j. Like I know the idea why it's good, but it's not something that I've had to use for my use cases. And I think that this is one of the most important things to say is that a lot of times as a professional developer, you learn things on an as-need basis. So knowing why they're good and their pros and cons is often more important than the actual implementation because you can look that up.
I remember when people started talking about Cassandra and I'm like, who is Cassandra? Like, I've never heard of her before.
I think, though, just knowing that these different things exist and the pros and cons of them can make it so that if you do have a use case where for some reason you need to analyze your data by column instead of row, then you're like, oh, okay, Cassandra should be something that I can research or something along those lines. But you don't need to know everything. You don't need to dive deep on every single database. Nobody has. So, yeah, that's a little bit of learning how to learn.
Back to it.
Right there. Back to that. We have an episode on that, not to get too pluggy. So to talk about how these databases are structured, especially with SQL databases, there are tables. So tables are a type of data. So again, we're going back to this dog example. Individual dogs could be a table. Owners could be a table. Breed could be another table. If it's a doggy daycare, maybe the days that they're in daycare. So you have these different tables to store different types of data. For a blog, it would be maybe a post and then a comment. Could be two of the tables that you'd have within that schema. And then there are columns. So columns are normally the pieces of information that you want to have for each dog. So for example, their age, maybe their weight, maybe their birth date. And then for breeds, it would be the breed itself, maybe some characteristics of the breed. For the owner, it would be their name and their phone number so that you could contact them. Those would be some of the columns. And then the rows would be the dogs themselves, the breeds themselves. And that's another really important part of these SQL databases. There are also IDs. So you normally will have a primary key that will be a unique identifier for each item in that database. So these will sometimes be serialized. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes you'll also see UUID, which is a randomly generated unique identifier. This depends a lot on use case and what you're needing to do there and what you need to do with them in the future. And then, so in a lot of databases, you model based off of the type's data. And so it kind of matches this object-oriented programming paradigm of relating your data to what's in real life, right? The idea of blog posts and comments and things like that, that kind of mirrors the way that you think about these things. And that being said, some NoSQL databases flip this on its head and you actually model your data based off of access patterns instead. So you know that you're going to need to get the posts with the comments attached to them. And so you model your data based off of that query rather than how things actually are in real life. And so it's a little bit of a different paradigm, but something important to note, especially DynamoDB. This is a big mindset shift from a SQL database. A lot of times people create ERDs too, which are entity relational diagrams that show how your data is related to itself or each other.
Cool.
That was good explanation.
I have nothing to add.
I'm just sucking it all in.
Cool. Do all those different pieces of data make sense and why you would need them?
They do, yeah.
It's essentially like an Excel sheet.
Yeah, exactly.
That's scaled up, especially for a SQL database. And I think that's why SQL is such a great entry point to databases, because a lot of people have used a spreadsheet before. And so you can kind of imagine your SQL database as an Excel sheet. Like, you probably wouldn't want to use Excel at scale because you can't have a bunch of connections to it, and it's not going to be able to scale with your
Emma's
app.
going to try.
Yeah, exactly. Emma, you can do it if you want to, but it kind of matches that same thing of having rows and columns and different tables. But again, this is different for NoSQL databases where you might just have an object instead, something that looks like a JavaScript object or a JSON. Okay, so now let's talk about accessing data. So some different ways to access data. There are ORMs, which are object relational models, I believe. And these allow you to access your data using the syntax of the programming language you're using. So maybe there'd be a Python ORM for a SQL database or something like that. Like Django and Rails have these built in. So if you've ever queried your data using a Ruby on Rails or a Django, you've probably used this abstraction on top of it that allows you to do that within Python or JavaScript, or Python or Ruby or JavaScript or whatever you're using. These usually handle things like SQL injection for you so that you don't need to implement that logic or anything like that. So we don't have a Bobby Tables incident. The ORMs kind of handle that for you. And so SQL, you need the SQL injection protection and make sure that nobody's hacking your database by inserting bad data. So ORMs usually handle that. SDKs are software developer kits. So a lot of databases will have these that you can install into your app and then interact with them via that. So
Shopify's a really great example of this because you don't have direct database access.
Yes.
You can use like their JavaScript by SDK, for example.
Yeah, DynamoDB as well as an SDK that you can use. So ORMs are usually more general to SQL in general. So the Django ORM you can use for Postgres or for SQLite or whatever flavor of SQL you're using. Whereas SDKs are more paired to the database itself. So they're a little bit more proprietary. Words are so hard. And then the last one is queries. So we talked a little bit about this with SQL already. Select star from your table name. That is another way that you can create queries. You normally don't want to have that lying in your code for security reasons, but that is another way to access your data, especially if you're trying to do data analysis or something along those lines. You'd also usually have an API on top of this so that you're not accessing your database directly from your front end for security reasons. So normally we have a whole nother episode this season about APIs, so go check that out. It's like GraphQL API or REST API. You normally have that built on top of your data and at the code layer instead of just pulling directly from the data in your JavaScript code or something.
It's worth noting that the APIs episode is our second to last episode of the season, so you're going to have to wait a little bit, but
you
will be able to learn about it.
Yes. These two episodes are pretty well paired, I think. So they could be good ones to listen to one after another. Okay. Any questions about ORMs, SDKs, queries, why these different things exist?
No, just lots of acronyms.
Yes. So many letters. It's like alphabet
I haven't done anything with ORMs. The other two, like SDKs, yes. SQL queries, definitely use those all the time. Just for looking at data, but ORMs were a little bit new for me.
Interesting. I think this comes into play a lot when you're using a backend framework. So if you've ever heard of Sequelize for JavaScript, that's an example of an ORM.
Oh, okay. Then maybe I have.
Yeah. Then there's also equivalent for NoSQL databases too. So there's like a MongoDB ORM for JavaScript. Let me see. Which is Mongoose. That's ODM.
Oh, okay.
So object document model instead of object relational model, I believe. So you may have heard of Mongoose. That's another example of an ODM for MongoDB.
I have totally used Sequelize before. So I didn't even
There you go.
That. Yeah.
So you have used an ORM.
Haha. See, this is my favorite part of being like a software engineer is you don't know what the hell you're actually using or what you know how to use. You just know how to use it.
Yeah, for sure. As need learned.
Yep.
Cool. So let's talk a little bit beyond the details. So we've talked about kind of the nitty gritty of how data is laid out and how you can access your data. Let's talk about horizontal versus vertical scaling. So we also talked about this in our episode about systems design. So this could be a good place to link that. But horizontal scaling means that you scale by adding more servers into your pool of resources. So instead of just having one server, you'd have multiple servers. Vertical scaling means that you scale by adding more power to your one server. So you'd have more CPU or RAM or storage to that one server. As you can imagine, Vertical scaling is a little bit more limited than horizontal scaling. You can only get a server that's so big, I guess, whereas you can keep adding more and more servers infinitely. And so here's where the big difference between SQL versus NoSQL databases come in. You are much more able to do horizontal scaling with a NoSQL database than a SQL database. SQL databases, you normally need to scale vertically. So you need to add more CPU or more storage to that one server, whereas NoSQL databases are better at existing on multiple servers and being able to scale across those. And the data format plays a lot into that. So imagine trying to join data from multiple different Excel books or Excel projects. It'd be pretty hard to match all that data up. Whereas if you have multiple JavaScript objects, it's pretty easy to combine those. And so that's why with NoSQL databases, you can do horizontal scaling, whereas SQL databases, you're more constrained to vertical scaling.
It's easier to do horizontal scaling, no? Like easier in terms of adding more like databases as opposed to like vertical scaling. You can't necessarily increase your storage super easily.
Yeah. Well, the cloud makes it so that both procedures are relatively managed, and there are a lot of serverless databases too now, which do all of the scaling for you behind the scenes. So if you hear of a serverless database, that's usually what they mean by that, or like a managed database. It means that they handle the scaling behind the scenes and you don't need to worry about it. That being said, again, there are more limits to how far you can get with a vertical scaled database. So I would think about that if you're trying to build something at hyperscale. Like most of these huge sites that you're using on a daily basis, like Twitter or Amazon or Facebook, they use NoSQL databases so that they can exist at this hyperscale more easily. But if you're building a personal blog, you don't need to worry about hyperscale. You do not need to worry about having a billion pieces of data stored at first. That's something that comes later.
What are some things that we should be thinking about when picking a database?
Yeah, so some things to think about: scalability. So the capability of a system to keep growing and increase in your demand. So any distributed system that can continuously evolve to the growing amount of work is considered to be scalable. So scalable if it can keep growing as your audience grows or your amount of data grows. Reliability is that a system will probably fail at some point, but how does it deal with that failure? And so again, this is one of the more difficult pieces of vertical scaling, is that you have this one database server, and if it goes down, then your database is down. Whereas horizontal scaling, one of your servers can go down and the rest of your system can keep functioning. Availability is the ability to give a response. Efficiency is how fast you can get the data back to somebody. And then manageability is the ability to actually manage it and scale it and make sure that it's still working properly. And then another thing to think about is how many connections that you can have to your database at once. So I think Postgres is limited to like 100 connections at once, I want to say. Something along those lines. It's in that area. So you can't have a bunch of apps connected to that one Postgres database because it only allows for a certain number of connections at once. Whereas if you have a database that allows HTTP requests to it, that can handle a lot more requests. A lot of these serverless databases or databases that are optimized to work with a serverless stack, like a AWS Lambda function versus a full-scale normal monolith Rails app or whatever, is that you want to look for a database that can handle a bunch of connections to it at once, because you have these serverless functions that are popping up. They need to make a connection to your database, and then they're essentially torn down. They're ephemeral. And so you need to really think about how many connections that database can take. Does that make sense at all?
Yes. It's just a lot. And it reminds me a lot of this reminds me of our systems design episode, which we did last season, I believe, in season 5, if I'm not mistaken. A lot of this yeah, we talked about at that point, because it's all related, right? It's relational.
It very much is. It is. It's a lot of the same information, just in a more specific format, I would say.
I have a really completely unrelated comment to make. I really appreciate your use of the word ephemeral.
I don't know.
It's one of those words like you don't often hear actually used in context, like in just casual day-to-day conversations. So I just appreciated it.
I feel like it's one that I use more and more since I work in serverless. It's something that you have to think about a lot. And so I get to bring these SAT words into my real life. Cool. Let's talk about one of my other favorite pieces of databases, which is indexing. So you can add indexes on a particular database or a specific column in a database or a certain field on it. And this is going to make it so that performing a query on that data is going to be much faster. So behind the scenes, they usually use either a balanced tree or a B tree or a hash in order to implement these. And you can select, okay, I want to index on this name column. I'm going to use this to query a bunch. And then you can make that much, much faster by implementing that index. I think this is very cool.
I've never heard of the balanced tree, yes, but the B tree?
Yeah, the B plus tree, I think, too. It's not even a normal B tree. I like it because it's these data structures that you hear about in like CS, but not too much on the job. And they're actually being used by people. They're actually useful.
Unlike the proofs that we learned in school.
I've never heard of indexing before, so I'm not very useful to this conversation, to be honest.
Oh, no. This is another one to think about as your data scales. Think about your data access patterns. What are the things that you're needing to query on a bunch of times? And then add an index to that column so that you can get that data back faster, especially as you grow. Because having these data structures means that it's going to be much more efficient to traverse the data than if you're having to loop through it. So we should do an episode on big O notation at some point. Have we done anything like that? We've talked about CS stuff, right?
We've just talked about some CS stuff, yeah.
We talked about it in the algorithms episode.
That's right.
Oh, yeah. Okay,
I don't know.
Check that out.
Yeah, I feel like it's hard to. I think they're related too much, and I think we've already done an episode. But if you would like to hear an episode specifically about runtime, performance, and like runtime, wait, those are the same thing. Performance and space, time and space complexity. Let us know.
Yeah, for sure. So think about it. So you want to go through your table and find every person named Steve, for example. If you don't have an index, you're going to have to loop through every single row and see if the name is equal to Steve, which is an O of N operation, right? You're looping through every single row and checking it. Whereas if you have an index, you could have a data structure that divides people by name in the first place. So then you only have to traverse a tree, which is O log N instead of O of N. And so that's much quicker. So that's why you add indexes to columns in databases.
It makes sense, but it's also difficult to visualize.
Yeah, for sure. It becomes more clear once you have these data access patterns. So if you're needing to access people by name a lot, or if you're needing to access, this is a good example. If you're needing to just access the columns that belong to the comments that belong to one blog post, indexing based off of the ID that links that comment to the post itself would make that query much more efficient.
Okay.
That would be a more real to world situation than querying on people's names, which could happen too.
Yep.
Finding all the Steves is important. Let's take some time for our mid-roll sponsors.
This episode is supported by Compiler, an original podcast from Red Hat discussing tech topics big, small, and strange. Compiler is brought to you by the creators of Command Line Heroes and is hosted by Angela Andrews and Brent Simoneau. It's no secret that technology can be complicated and frankly a little intimidating. Compiler unravels industry topics, trends, and the things you've always wanted to know about tech by interviewing the people who know it best. I checked out the Should Managers Code episode where the hosts discussed the 80-20 rule. 80% of a manager's time is typically devoted to managing, while 20% is devoted to coding and problem solving. They discuss how it can be hard to close the door on your identity as a creator, something many new managers struggle with. The hosts also discuss how you can keep your skills sharp when most of your time is spent managing. I thoroughly enjoyed this episode, and I know you will too. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. We'll also include a link in the show notes, and many thanks to Compiler for their support.
Welcome back. Let's chat a little bit about scaling again. So there's this concept of having primary and replica databases, and this allows you to have multiple databases that are copies of one another that exist across different servers so that you can have this horizontal scaling so that if something goes down, that's okay. So the primary database is used for write operations. So if you need to mutate data in some way, then you use that primary. Whereas most queries are actually read queries. So you're just getting the data back instead of creating data or updating it or deleting it. And you'd use the replica databases for those read operations. And so most apps have more reads than writes. And so this ends up working pretty well where you can be querying these read databases and then writing to that primary. And the replicas are mirror images of this primary database.
I'm trying to figure out like a situation where I would use this.
This again comes into play for scale. So a Twitter-sized application, for example, querying just one database, it's going to put too much load on that one database. And so if you want it to become faster, you'd have the one database that people write to, but then all these mirror ones that people can pull their timeline from.
Okay. So I guess in like the scale at which I build, it really does not make sense to do something like this.
Like we definitely do not need to do this for the Ladybug site. But if you're building Amazon.com, you might need to do this. Yeah. But then again, a lot of these companies use NoSQL databases, which handle this pretty well as is. This is more into play for SQL databases. There's also sharding, which is our favorite term of all time. It's not sharding. There's a D. Not a T. And this is where you separate a large database into smaller ones. So they have the same schema, but the data is unique to each shard. And then you use a hashing function to find the database that your data is actually stored in. This can be difficult when you're resharding, when a single shard can't hold more due to growth or uneven data distribution. So there's this idea of the celebrity problem. So if you have Google, for example, people are going to search for Ali Spittle very rarely. People do not search me all that often, though it is probably more than some rando on the street. That being said, people...
What if that rando on the street is like actually, some famous musician?
Yeah, then they definitely get way more. Yeah, then they definitely get more Google searches than I do. I don't think many people search for me. But sometimes you have Lady Gaga. Lady Gaga in a phone book is going to get a lot more people looking her up than me. And so if a lot of people are looking up Lady Gaga and she's in one shard, that can make it so that that server is overloaded just because of Lady Gaga. And this is called the celebrity problem. And so joining and denormalizing data can become really, really hard to do across shards as well. So if you're trying to join data from this one shard to another, it gets really complicated. And so sharding is important to have this data stored in multiple places, especially if you're trying to really scale your app. That being said, it can become pretty difficult and there's some problems with it. Any other thoughts on sharding other than the name?
I can do an entire episode on sharding, but it's not this time.
I don't think that's what our podcast talks about. So let's talk about something that's maybe related.
like data partitioning. I'm not sure that that's like related to sharding at all.
Let's talk about data partitioning.
Your loss.
Yeah. So both of these primary and replica databases and sharding are both part of data partitioning. And again, there's this horizontal and vertical movement. Horizontal is putting things across servers, and then vertical is just scaling that server up. Okay, we're almost there. I just have two more things that I want to talk about. The first is migrations. So when you're working with a SQL database, you have a schema declared for it up front. So there are certain types of columns and certain tables that you have set up at the beginning of the app. That being said, a lot of times this is going to change over time. So for example, Twitter just implemented this dislike button, right? And so that's going to be a different column in the database that they're going to store that downvote on, or maybe even multiple columns in a table. And so when this happens, you create what's called a migration to change your data over to that new format. And so this happens a lot for a lot of applications at the application level. So Ruby on Rails or Django, they handle this migration process for you. So in your code, you write the migration script and then it's done for you. It's important to keep these migration files because it shows the evolution of the database over time and allows you to roll them back if something goes wrong. So if for some reason you're trying to add this new column and your database is not handling it well, then you can roll it back and go back to that previous version more easily. So that's migrations. Have you all used those before?
Not at all.
Have been affiliated with people who have used them.
There you go. Well, if you've used SQLize, they do migrations, I believe.
Yeah. So it wasn't anything like I particularly like wrote or had to do, but I had to tangentially use them, if that makes sense.
For sure. It's actually really interesting because some full stack frameworks, they do the migration for you. Other ones, you write the migration. So in Ruby on Rails, you write the migration and that updates the database. That being said, in Django and I think SQLize, I forget, it's been a while since I've used SQLize, but you change the data model in your application and then they write the migration for you. So it's interesting how that changes from framework to framework. And another thing that I want to briefly chat about is the CAP theorem. This is one of the really important pieces of systems design. And this is the theorem that states that you can only have 2 out of the 3 between consistency, availability, and partition tolerance. So consistency is that everybody is getting the same data at the same time. Availability is that no matter what, you give a response. So there's always some sort of response available. And then partition tolerance is that you can have multiple partitions of your data. So this CAP theorem says that you can only have 2 out of the 3. You have to sacrifice 1. And different databases have different 2 out of the 3 that they implement. And so that's something to think about when you are choosing a database as well, which ones are the most important.
This is maybe a stupid question, but like, do you ever think there will be a database that doesn't have to sacrifice 1? Or is that not even possible?
I don't think it's possible. I think that's the idea of the theorem, that like can't happen. I mean, you never know the future, but just from a logical basis, unless there was some super powerful internet that can't go down or something like that, I don't know how it would happen. So again, a lot of SQL databases are not partition tolerant. So that means that you can't have multiple partitions of that database. And if you need to have a front end for your application, that kind of counts as a partition as is because you're trying to access the data from multiple places. Availability, if you want to have offline data for your application, you need to have availability included. That's another thing to think about. And then consistency. This is the one that I see most often sacrificed with NoSQL databases, where they sacrifice consistency for eventual consistency, which means that at some point the data will all line up, but not immediately. So it may take a few minutes for the data to be equal across all these database servers. So that's probably the most frequent one that you'll see sacrifice is consistency, and they sacrifice it for eventual consistency.
I feel like generally speaking, it would be impossible to have this perfect situation where you don't have to sacrifice one. Like in what area of life for anything do we have this perfect scenario where it's like the client dilemma? Pick 2 out of 3. Do you want fast? Do you want it fast? Do you want it right? Do you want it cheap? Can't do all 3 ever.
For sure. Cool. Well, any other database talking points that I left out?
I would love to know what databases are.
Good. I think we're a little late on that one. But they're a thing that stores data.
There's no hope for you anymore, Kelly.
Finally, somebody admits it.
It's actually kind of a hard thing to define other than with the term data, I think.
Yeah.
Stores your application information.
It's a table. I don't know. Yeah. This is a really difficult thing to define.
It is.
I would Google it, but that's cheating.
Yeah. Somebody has explained it, I'm sure, at some point.
You can't, nothing defines database without using the word data. Oracle has, as a database, is an organized collection of structured information or data, typically stored electronically in a computer system.
Having an on-paper database would be pretty fun, though.
No, thank you.
Yeah.
I'm good, thanks.
I don't know. You could just hire a bunch of people to write down all the information for your app and then type it back out. It'd be pretty iconic.
All right.
Cool.
How about we do some shout outs?
Let's do it. Emma, I'm going to put you on the spot.
Okay, this is going to be a weird shout out. The first book that I bought on my Kindle is called Hidden Valley Road. It's a book about a family who had 12 children, 6 of which were diagnosed with schizophrenia. And they kind of, like, studying these 6 children or adults at that point really kicked off a lot of the research around schizophrenia that we have today. And it goes into a lot of the nature-nurture discussion of schizophrenia as a mental illness. So I think it's a really fascinating book. And if you just be aware, there are trigger warnings for a lot of really difficult topics. So just maybe look into that if you have difficulty reading about certain topics that I'm not going to say on this podcast. But it's a very interesting book. Highly recommend it. Kelly, how about you?
So I started a newsletter that I'm calling Your Friend's Guide to Entrepreneurship. And I'm emailing out every Friday morning. It does not take any more than 5 minutes to read each newsletter because time is limited. I'm having a lot of fun writing it. And if you would like to subscribe, I am currently buying the domain yourfriendsguidetoentrepreneurship.com as we speak.
Ooh. You know what's going to bother me about that is that you can't have apostrophes in URLs, but sure.
I can't help you with that one.
I know.
You gotta go reinvent the web for that one.
Allie, what about you?
Yeah, mine's a weird one. I've been using the Peloton app.
Yeah.
I don't have I don't have the bike or the treadmill or anything fancy like that, but I do have the app, and they still have a lot of really great workouts, even though you don't have the machine. So if you have a Chase Sapphire Reserve credit card, they have like a free subscription right now. So just a little bit of a plug.
Yeah. And if you don't, it's $12 a month for the app.
Yeah. Okay. Pretty affordable.
But they have
less than a gym membership.
Like strength-based workouts. So like upper body, core, lower body. There's bar, there's Pilates, there's stretching. All of these are available on the app. Highly recommend. I think I'm contractually obligated to talk about Peloton at least 4 times a day since I do own a Peloton. So we'll count this as one of those. I just realized that I bought the domain yourfriendsguidetoentrepreneurship.com. I even bought the wrong domain name.
Oh, no.
Speaking of $12 that I just threw away.
Shout out to all my dead domain names like it's time for .wine and catgenerator.com.
There you go. You got to have those domains. If you like this episode, go ahead and tweet about it. We'll select one tweeter to win a copy of the DynamoDB book by Alex Debris. It's amazing. I learned a ton from it, so be sure to tweet. We post new podcasts every Monday, so make sure to subscribe to be notified and leave a review.